In the previous video, we looked at short line segments versus long line segments and saw that the length doesn't matter, they both have an infinite number of points. So today's video is, well, does a 2D shape have more points than a 1D shape? Now we're not even just longer in 1D, now we're in 2 dimensions. So again, the intuition might be, I mean, come on, surely this must have more points, this whole area, than just this line segment. Or an infinite line, doesn't matter. Now, okay, so let's get into that. So what do you guys think? So think to yourself and see what your ideas are. So one idea might be, well, you know what, maybe they're the same, but we'd have to, if you remember the rational versus irrational number video, where we had that snake argument, maybe we can snake our way through this somehow and hit all the points. So if we went this way and then kind of snake back, we could sort of do this. Perhaps, but the problem is as soon as you go up, no matter how little you go up, you're gonna miss a little bit of a slice. So maybe you're thinking, okay, there's probably a larger infinity here. And that's a perfectly reasonable thing to think, except that it's wrong. And there is a very incredible way to show that there's in fact the same number of points in both. Now, how do you do that? I'm going to give you guys a very, very quick overview in a few seconds, and then I'll give you a few comments. So keep in mind, this diagram that I'm about to draw is terrible, but it's just to give you an idea. So if you create a super intricate curve, which looks something like this, again, please don't even spend too much, I hear laughter, great. So don't spend too much time looking into this. But if you create a very intricate, in fact, infinitely intricate curve, which is called a space-filling curve, and it's also known as a fractal. By the way, I'm going to do a video on fractals coming up, and there's going to be a ton of links there. So again, please, this is the saddest thing in the world, so please do not go off my picture. This is just to introduce you guys to this idea. So I have in the description to this video a lot more links, both to articles, to other videos that do a much more beautiful job of doing this. So I want to make this point that, as you guys probably have seen at this point, there's kind of well, there's several themes, but math-wise, so let me sort of give you the 3 themes. So first theme is I'm about efficiency and helping you guys get actual skills on this channel. Second thing is about that creativity and showing math can be fun and beautiful. So that's the second thing. And the third thing is just to help your overall development as a student and person. But if we focus on those 2 things, drawing pretty diagrams and having fancy YouTube videos is not my style, and it's not my strength, and that's not what makes me excited. So I encourage you guys, that's not to bash that stuff, but I'm a no-nonsense sort of person, but I do like to have fun and the beauty stuff. So if you want that aspect of it, go see those links, and there's nothing wrong with it. In fact, it's going to complement your understanding, and it's a really cool thing to see. That said, you know, I don't want to spend weeks and weeks working on one video for you guys and not present all this other stuff that could be helpful for you right now. So I've made a decision to give you more content rather than to make it super pretty and fluffy for you guys. So please, this is just to give you the idea. So if you're like, wow, that doesn't look convincing at all. So the idea is, in our first argument where we had that snake thing, and I said, as soon as you move up, you're sort of going to miss a little slice. You could say, well, hey, well, why, as soon as I move up over here, I'm going to miss like this piece right here. But that's where the details are important. This is an infinitely intricate thing. So the way I've drawn it, this is not a straight line. So if you were to zoom in on this tiny little segment, you'll see that segment in itself, if you were to zoom, is gonna itself be something else. Now, like you're like, oh, but I found it, here it is. If you zoom into this, you'll find that again is not a completely straight line. So in this devilish clever way, we're gonna actually create this super packed curve that's going to hit all of these points. So I'll leave it at that. I really recommend you guys check out the links that I'll put in the video. So I'm not going to make a separate video on 3D shapes, but at this point you're thinking, okay, well, surely if I have a cube, or a lot of you might be onto this now, like, well, maybe you could do the same thing for a cube. So in fact, you could apply the same argument for 1D versus 3D. And again, if you have some really crazy contorted line that's fractal, and we'll go into what that means in a future video, you can pack the cube with a 1D segment. So there's an equal amount of infinite number of points in 1D, 2D, and 3D, and actually higher dimensions, I believe, but I'll leave it at that. So that's a pretty shocking thing. I was pretty surprised when I saw that. So definitely encourage you guys to read more. Please check out the description and watch the far better videos that are out there, but I just want to give you guys a quick reference so it's on your radar. All right, see you guys in the next video.